Hey, welcome to another lesson. So we are gonna move to friction, which we've obviously mentioned before, but haven't really covered it. So friction is a type of resistance that takes place in rough surfaces. Now, just before I get on to friction, just one concept that we need to cover, which we might have done, but just a quick recap. When a particle is in equilibrium, that means net force is zero. Okay. What that means is your acceleration will be zero. So when you do F equals ma, a will become zero. And equilibrium basically means the particle is either at rest or moving at constant speed. But the main thing you need to know about equilibrium is that acceleration is always zero. Right. We'll come on to this when we get these type of questions, but moving on to friction. Right. So friction is a type of resistance force. There's lots of resistance forces that exist in real life. You have, um, air resistance, for example. Friction will be the main one that we will encounter in this course. So usually friction takes place when two surfaces are sliding against each other. Yeah. Now, friction also takes place when an object is not moving. Okay, so this is when you have a maximum friction, right? Now, for example, if you try to push a truck, right, the truck is not gonna move, um, and this is because there's a friction between the truck and the road. And this causes the truck not to move when you push it. In order for you to, in order for the truck to move, your pushing force has to be higher than the friction. Okay. But the reason the truck is not moving is because the pushing force isn't enough to exceed the maximum friction. Okay. So there's a maximum friction which is present in between every object and the surface it is on. Okay, so two types of surfaces which we've covered before. Smooth surfaces are without friction, and rough surfaces are with friction. Um, in terms of direction, friction is always opposite the direction of motion. Okay, now if you look at this first example, the car is moving to the right, so the friction will be to the left. Yeah. If you look at the second example, the car is driving diagonally upwards, so friction will be diagonally downwards. Okay. And if you look at the third example at the bottom, now this is the pulling force, right? P stands for pull or push, depending on the situation. So the box is being pulled by this diagonal force, okay? But the motion is in this direction, right? When you pull the box, it's not going to lift in the air. You're sliding it this way. So this is where your motion or travel is. Okay, so in this case, because the box is traveling horizontally, your friction would be to the left. Okay. Right, now this idea of some maximum friction, right? So if you look at this specific example, an object is at rest on a table, the maximum friction is 17. Okay. I apply a horizontal force, a pushing force of 10N, right? So there's a pushing force of 10. Okay. But the object doesn't move. Right now, what that means is I'm pushing it by 10. The friction is traveling opposite by 10. Now this keeps the particle at rest, okay? Because the left is equal to right. Okay? This means that the object is not moving because the resultant is 0. Okay. Now, some of you might be wondering, if the maximum friction is 17, why have I put 10 here? Right now, if I put 17, what will happen is the object will move to the left, right? Because there's a left force of 17, which is greater than the right force. So obviously the object will move. Okay. The maximum friction basically means you need to apply enough friction to keep the object at rest. So if I'm pushing by 10, the friction applied opposite will also be 10 to keep it at rest, not move. We don't need to have a 17 friction here. Okay. Similarly, if I applied a 15 pushing force, right? What would happen is there will be a friction of 15. Again, this would keep it at rest because left is equal to right. Okay. If I applied a push of 17, again, there will be a friction of 17. Okay, this will keep the object at rest. Now, if the pushing force goes above 17, obviously your friction can't go beyond 17 because that's the maximum. Okay, so it says now I apply a pushing force of 20. So I'm pushing it by 20. Okay, your friction would stay 17. Your friction can't go beyond 17 because that's the maximum. And then you can apply F equals ma, depending on the question and what it asks. Now, in most of the questions, you don't have to worry about maximum friction. It will give you a friction value and you use that. It's only in certain scenarios where the object is at rest. That's where it matters, right? Mostly you will have one single value for friction. Right, let's have a look at this question. Okay. So part A, an object particle of mass 7 kg is at rest on a rough table. It is pulled by a horizontal force. Okay, so a horizontal force of 15N is pulling it, but it stays at rest. Okay, now if it's being pulled by 15 and it stays at rest, that means the friction will also be 15. Okay, because in order to keep it at rest, you need to have the same right and left force. Okay, so if right is 15, left is 15, keeps it at rest. So when it says find the friction, it's basically 15. Okay, part B. Sorry, just going back to part A, you can actually calculate it if you wanted to. So if you did friction here, okay. Now at rest means A is equal to 0. Okay. So when we do F equals MA, we can do right minus left or left minus right. Doesn't matter. Okay. So going right is 15. Going left is friction equals to MA. M is 7. Okay. And your acceleration is 0 because it's at rest. If you solve this, it gives you friction equals 15. So what we got at the start. Okay, now part B, the pulling force is now 45. So it's being pulled by 45. And friction will be opposite the motion. So friction is here. And the object now moves with acceleration equals 3. Okay, now the object is moving to the right. Yep. So we will do right minus left equals ma. Going right is 45. Going left is friction equals to ma. Now m is 7 and a is 3. Okay. So 45 minus friction equals 21. And your friction will be 45 minus 21, which gives you 24 newtons, right? So again, these are basic questions just to give you an example of how the friction force works. Okay, now in terms of surfaces, obviously I told you there is a friction between surfaces, but we need to be very, very precise when it comes to friction, right? So there's a concept called coefficient of friction. It's denoted by a letter mu, okay, which looks like a U. It's just an extra stick at the start. Right, so this is a measure of the amount of friction between two surfaces. Right. Now, if the coefficient of friction is low, that means there is little friction. Okay. So for example, if it was 0.1, that means very less friction. If it was 0.9, that would mean high friction. Okay. Generally, it's between 0 and 1. Right. Now, slippery surfaces like ice, they have a low coefficient of friction. So maybe around 0.1, 0.2. Um, so for example, if you were to push something on ice, it easily slides, right? That means there is very low friction. Now, the coefficient of friction is measured um, according to two surfaces, right? So you can have plastic on ice, steel on ice on ice. So it's two surfaces which determine the coefficient of friction. We don't need to worry about the theory in this. We just need to know that there is a coefficient of friction and how it works. Right, now we use a formula which involves coefficient of friction. Okay, so this is the formula. It's friction equals mu times n. Okay, so Fr is friction, mu is the coefficient of friction, and n is the reaction force. If you can't remember the reaction force, remember this is the reaction force which acts right angle to the surface. So friction equals mu times n. This is the formula for friction that we use. Now, this is when the particle is moving or at the point of moving. Okay, so these will be the main scenarios which we will have in our sort of questions. Okay, now sometimes the particle is not moving, right? So, for example, the questions we did at the start, the maximum friction was 17, but the actual friction can be less. Okay, in that case, friction is less than or equal to mu n. Okay, because the actual friction can be less than the maximum one. Okay, but this is the main formula that we need for solving. Right, have a look at this question, pause it, and then resume when you're ready. Right, so we have a diagram here. There's a particle of 5 kg with certain forces. There's a 14 downward force, 16 driving force, and friction is here. Now, there are some forces missing. One is the weight, okay, mg. So for Cambridge, we use g as 10. If you're at Excel, use 9.8. So mg will be 5 times 10, 50, okay? And the normal reaction is going upwards. Right. It says part A, find the frictional force. Now we know that friction equals mu n, right? Now we know that mu is 0.2, so we can replace that with 0.2. So friction equals 0.2 n. Right. The problem is we don't have n. So first we need to find n. Okay. Now this particle is moving horizontally. There is no vertical movement, right? So vertically, acceleration is 0. Okay, so we can do up minus down equals ma. Now, what's going up? We have n going up. And what's going down? There are two forces going down, 14 and 50. So combine them together. Up minus down equals ma. Right, so n minus 64 equals 0, which means n is equal to 64. Okay. Once you have your n, you can substitute into your friction formula. Friction is equal to 12.8. Okay, now we've got friction, so we can replace friction with 12.8 here. Okay. Now, part B says, will the particle accelerate? Okay, so we do part B here. Now, the object is moving to the right, right? Because 16 is going to the right. So acceleration is to the right. We do right minus left equals ma. Going right is 16, going left is 12.8. Mass is 5, and A we don't know, so label that A. Okay, and let's solve this. So that gives you 3.2 equals 5A, and then A equals 3.2 divided by 5, which will give you 0.64. Okay, try this yourself. So read the question, pause it, and then resume when you're ready. Right, so when drawing the diagram, always start with the surface. What's the surface? Is it horizontal? Is it diagonal? So it's a rough horizontal ground, right? So the surface is horizontal, 5 kg, so weight is 50, normal reaction N. There is a horizontal force P applied to the block, which you can do like that. Um, you can also do it the other way, like this. It's entirely up to you. I just prefer going from sort of left to right. Okay, so this is applied to the block. Um, Now, if P is applied this way, that means object is moving to the right. That means friction will be in the opposite direction. And you have the coefficient of friction, which is 0.4. Okay, now the friction formula would be mu n. Sorry. Okay, now let's find n first. So um, remember, this is horizontal motion, so there's no acceleration up and down, right? So your normal reaction is 50. You substitute that into your friction formula, right? So friction will be 20, okay? And then it says P is 30. Okay, so change P to 30. Friction we already know is 20, right? So we've got those. Now the object will be moving to the right, okay, because 30 is going to the right. So right minus left equals MA. 30 minus 20 equals 5A. Okay, right, have a look at this. Pause and then resume. So rough horizontal floor. Right, the weight going down is mg, so 0.8 times 10 will be 8. And going up is your normal reaction. Right now, if we use the friction formula, okay, now we don't know mu, we don't know n, we can't find n. Um, n will be 8 here, right? Because um, going up is equal to going down. You can obviously I can do the formula for you. Up minus down equals ma. Right, there's no acceleration vertically, so 8 minus n equals 0, n equals 8. Okay. So n is going to be 8. Friction equals 8u. Um, but now we're stuck, right? We don't know what um, mu is. We don't know what friction is. We don't know what acceleration is, right? So in this case, we can use they've given you the speed and the distance, right? So memory recall, going back to Suvat, okay? Initial speed is 2, final speed is 4, distance is 4.8. How can we find the acceleration? Okay, so this formula links all of those. V square will be 16, U square will be 2 square, which is 4, plus 2 times A times S, which will give you 9.6A. Right, that means A is equal to 12 divided by 9.6. If you do that on the calculator, you should get 1.25. Right, once you've got your acceleration, we can use F equals ma horizontally. Okay, now the object will move to the right because it's being pushed by a force of 7. Yep, going to the right. So right minus left equals ma. Going right is 7, going left is your friction. Okay, mass is 0.8 and A is 1. We are out of space. Right is 7, left is friction. 0.8 times 1.25. Now, if we try to solve this, 0.8 times 1.25 is 1, and this will give you friction equals 7 minus 1, which is 6. Right, so we've got the friction, and now it wants the coefficient of friction. Okay, so this is what we had at the start. Friction equals 8 mu. Friction is 6, so we replace friction with 6, which we just calculated. Okay, and then mu is equal to 6 divided by 8, which is 0.75. Right, so they brought Suvat back into this, so you have to be ready for previous topics. Mechanics is all mixed. Right, so once again, have a look at this one, pause and resume when ready. Okay, couple of forces here. Um, there is a diagonal force of 56N. Now, again, because it's a horizontal surface, we want all our forces to be either horizontal or vertical because they have to be right angle. Okay, so we don't want this diagonal force. So with this 56 diagonal force, I am going to calculate both the horizontal and vertical components, right? Now we are starting here and going down there. So we will go down vertically and then right to the end point. So these will be our two directions. Okay. Now the opposite is sine. Let's make a bigger one so it's easier to visualize it. Right, so we are starting here and going down to the bottom. So we will go down and then right. Now, this is your force, 45. Right, opposite is your sign. Okay, so if I go directly opposite right through this, okay, this will give me 56 sine 45. Okay, and the other force is adjacent, that will be cos. So that will be 56 cos 45. Okay, the other forces that we have, so 5g is the weight. Now we know that g is 10 for Cambridge, so this will be 50. And we have the normal, we have the friction. I'm just gonna put an R there, FR, just to make it easier. And they have given you the coefficient, which is 0.2. Okay, so now we can begin the question. The first thing to do is find n. Okay, now the object is moving left or right, right? Because it's a horizontal surface, so there is no acceleration vertically. Right, so vertically acceleration will be 0. So we can do up minus down equals 0. Okay, now going up is just n. Going down, you have two forces. One is your 56 sine 45. Okay, and you also have going down the 50 weight force. Okay, using this, we can calculate our n. Right, so n equals 89.6. Right, once you've got your n, we can move on to friction. Right, so 0.2 times 89.6. That should give you 17.92. That's your frictional force. That's your part A. Now, moving on to part B. Um, Now it says, will the particle accelerate? Now the particle will move to the right, okay, because the pushing force, which is 56, is being applied towards the right. So we will do right minus left equals ma. Now going right, we have one force, which is this one, 56 cos 45. This is going right. Going left is our friction, which is here. Now we know that friction is 17.92. Going left, sorry. Yeah. Okay. Equals to MA. So M is 5 and A we don't know. Okay. Now let's try solving this. So 56. Right, you get acceleration equals 4.34. Right, have a look at this one, pause, and then resume when ready. Right, so again, start with the surface, rough horizontal table. It's horizontal, yeah. Particle of mass 5 kg. Now it's being pulled by a force of 15 N acting at 20 degrees above, right? Now, because it's pulling, you would take it up. This would be a pulling force, and the angle is 20 degrees. Okay. If it's a pushing force, then it goes down like that because you're obviously pushing, so you will push down. Now, the friction force is 10N, right? Now, if you look at the pulling force, it's 20 degrees, so the object will move to the right. Now, friction will be opposite, which is this way, and the friction will be 10. Okay. This force was 15, the pulling force. We have a normal force here, and the weight will be 50. Okay, first thing, now again we have a diagonal force. We need the vertical and the horizontal component of this. So okay, you will have a, let's make it this way. Yeah. Now, this is the opposite, so that will be 15 sine 20, and this is the adjacent, so that will be 15 cos 20. Direction is really important. Now, if you look at the original force, it was starting over here, ending there. Okay, so if you go along the path from here to here, right, and then up, we will end at the same point. Now, once you've got these, we can use F equals ma. Now, again, the particle is moving horizontal. That means vertically there is no acceleration. So up minus down equals ma. Going up, we have two forces. So we have N, and we also have this force going up. And going down, we have the weight, which is 50. And M is 5, acceleration is 0. Okay, now let's try finding N. Okay, so N equals 44.87. Now the formula for friction is friction equals mu N. We know that friction is 10. Okay, and we know that N is 44.87. Okay, so we can find the coefficient doing 10 divided by 44.87. That should give you 0.22. Three. Okay, we'll stop there. And in the next lesson, we will look at diagonal surfaces included with friction. Okay, see you soon.